Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my fifth lecture in our subject, IT 112, Discrete Mathematics. In my previous lecture, you learned the miscellaneous counting methods such as permutation involving n objects that are not distinct or identical and not distinguishable with repetition, and combination with repetition. Today we are going to learn another miscellaneous counting methods, the Catalan numbers. B sub n is equal to C2n, n minus C2n, n minus 1 is equal to 1 all over quantity n plus 1 multiplied by C2n, n, where n is greater than 1, and B sub 0 is equal to 1. The sequence of integer numbers b sub 0, b sub 1, b sub 2, up to b sub n are called the Catalan numbers, after the Belgian mathematician Eugene Charles Catalan, who used them in determining the number of ways to parenthesize the product x sub 1 multiplied by x sub 2 multiplied by x sub 3 multiplied by x sub 4 multiplied up to x sub n. The first 7 Catalan numbers are b sub 0 is equal to 1, b sub 1 is equal to 1, b sub 2 is equal to 2, b sub 3 is equal to 5, b sub 4 is equal to 14, b sub 5 is equal to 42, b sub 6 is equal to 132, and many more. The Catalan numbers are used to count how many ways to parenthesize the product of algebraic variables. Example number 1. Determine the number of ways to parenthesize the product x sub 1 multiplied by x sub 2 multiplied by x sub 3 multiplied by x sub 4. Solution. There are 5 different ways to parenthesize the product x sub 1 multiplied by x sub 2 multiplied by x sub 3 multiplied by x sub 4. And here are the 5 different ways of parenthesizing the 4 algebraic variables. So, how do we use the Catalan numbers formula to count how many ways to parenthesize that product? In general, one can parenthesize the product x sub 1 multiplied by x sub 2 multiplied by x sub 3 multiplied up to x sub n and b sub n minus 1 ways. Knowing this information, the number of algebraic variables given in the statement of the problem are 4. Therefore, to calculate the number of ways using the Catalan formula, we subtract a1 to that 4, so 4 minus 1 is equal to 3, and that will be the value of n. So, we are going to calculate the Catalan number at b sub 3. Using the formula, b sub n is equal to 1 divided by quantity n plus 1 multiplied by c 2n, n. We substitute the value of n by 3, so b sub 3 is equal to 1 divided by 3 plus 1, quantity 3 plus 1, multiplied by c, 2 multiplied by 3, 3 is equal to the 1/4 of c, the number of combination of 6 objects taken 3 at a time, 63, is equal to 1/4 of 20, is equal to 5 ways of parenthesizing the 4 algebraic variables. The Catalan numbers are used to count how many arrangements of n ones and n negative ones with all 2n partial sum non-negative or positive for n is greater than or equal to 0. Example number 2. In how many ways can one arrange 3 ones and 3 negative ones so that all 6 partial sums starting with the first sum are positive or non-negative? There are 5 different arrangements of arranging the 3 ones and 3 negative 1 so that the 6 partial sum starting with the first sum are positive. For example, 1 plus 1, the sum is positive. To be added to 1, it will become positive 3. So therefore, the first starting sum must be positive. The example number 2 of arrangement, 1 plus 1 is positive. How about this number 3? 1 minus 1 is 0, and 0 is positive. And then if you add it with a 1, it is a positive or non-negative. Example number 4 is 1 plus 1 is positive. 1 minus 1 is positive plus 1, it is positive. Here is another example which is not included in the list of arrangement that I like to show as a good example that does not obey the rule of starting with the first sum as non-negative or positive. If we look at the starting sum, negative 1 minus negative 1, it is negative 2. Therefore, it does not obey the rule that the starting value should be first sum. So that is how we understand this problem. So therefore, how do we apply the Catalan numbers formula to determine the number of ways of arrangement of 3 positive 1 and 3 negative 1? In general, for n is greater than or equal to 0, one can arrange n ones and n negative ones with all 2n partial sum non-negative. This 2n indicates the number of digits. If there are 3 1 and 3 negative 1, that is the value of n. So the value of n is 3. 2 multiplied by 3, it is equal to 6. So if we arrange the 3 1 and 3 negative 1 and count how many digits, it is 6. With all 2n partial sums non-negative or positive in b sub n ways. Therefore, to compute the Catalan numbers, the value of n is the Catalan number that we are going to calculate. Here in this case, the value of n is 3. Therefore, we calculate the Catalan number at b sub 3. Using this formula, b sub n is equal to 1 divided by quantity n plus 1 multiplied by c2n, n. We substitute the value of n by 3. So b sub 3 is equal to n plus 1, 3 plus 1 multiplied by c, 2 multiplied by 3, 3 is equal to 1/4 of the combination of 6 objects taken 3 at a time is equal to the 1/4 of 20, and then the answer is 5 different arrangements or ways. Example number 3. Given 4 ones and 4 zeros, there are 14 ways to list these 8 symbols so that in each list the number of zeros never exceeds the number of ones, as a list is read from left to right. The solution is already given that there are 14 ways to list the 8 symbols consisting of 4 positive 1 and 4 positive zeros. That the number of 0 never exceed the number of 1, or the number of 1 is always at least as greater as the number of 0. Let us try to understand one of the examples of the 14 different arrangement. For example, this arrangement, if we count the number of 0 that we read from left to right, so the number 1 indicates 1 count for the 1, 0, is indicating one count for the 0, and then the third digit is 1. So therefore, there are two ones and 0 and 1 0. Therefore, the number of 0 never exceeds the number of ones. Another example, there are three ones, so it is evident that 0 is lesser than the number of counted 1, which is 3. How about this one? There are two ones. It is evident that there are less number of 0 as we count comparing to the number of ones. So that is how we understand the problem. The number of zeros never exceeds the number of 1. Or in other words, the number of ones is always at least as greater as the number of zeros. So therefore, how do we apply the Catalan numbers to compute the number of ways to arrange the 4 ones and 4 zeros? That the rule is that the number of zeros never exceeds the number of ones. For n is greater than 0, there are b sub n such list of n ones and n zeros that the number of ones is always at least as greater as the number of zeros. So therefore, the number of ones and zeros is 4, so that will be the value of n. And then we are going to calculate the Catalan number at b sub 4 using this formula. B sub n is equal to 1 divided by quantity n plus 1 multiplied by c 2n, comma n. We substitute the value of n by 4, so b sub 4 is equal to 1 all over quantity 4 plus 1 multiplied by c 2 multiplied by 4, comma 4 is equal to the 1/5 multiplied by the combination of 8 objects taken 4 at a time is equal to 1/5 of 70, and the answer is 14 different arrangements or list. The Catalan numbers are used to count how many times the CPU executes an instruction composed of n nested for loops. Example number 4. How many times the CPU executes the instruction count is equal to count plus 1, given these nested 3 loops. The solution, we simply read those 4 loops. The main loop for I sub 1 is equal to 1 to 1, and then the second loop for I sub 2 is equal to 1 to I sub 1 plus 1, and then the next loop for I sub 3 is equal to 1 to I sub 2 plus 1 up to the loop for I sub n is equal to 1 to I sub n minus 1 plus 1. Then the value of the count, the number of times the CPU will execute this instruction, count is equal to count plus 1 for this nested loop, is b sub n, where that n indicates the number of that sentinel variable that controls the loop. So therefore, how do we apply the Catalan number formula to count how many times the CPU executes the instruction, count is equal to count plus 1? Here in this given problem, there are 4 loops, and then we have 3 sentinel variables, namely I sub 1, I sub 2, I sub 3. Therefore, the count for that variable n is 3. So n is equal to 3, and according to the solution previously that we learned, to count, to know the number of times the CPU executes the instruction is b sub n. So therefore, we calculate the Catalan number at b sub 3. So b sub n is equal to 1 divided by quantity n plus 1 multiplied by c 2n, comma n. N is 3, so substitute. B sub 3 is equal to 1 divided by quantity 3 plus 1 multiplied by c multiplied by 2 multiplied by 3, comma 3 is equal to the 1/4 of the combination of 6 objects taken 3 at a time is equal to the 1/4 of 20, and the answer is 5 times. Therefore, the CPU executes this instruction count is equal to count plus 1 5 times. 5 times. The Catalan numbers are used to count how many ways to arrange integer numbers to be placed in a 2 multiplied by n positions of a 2 multiplied by n monotone array. Example number 5. How many ways to arrange the integers 1, 2, 3, 4, 5, 6 in 2 rows of 3 columns so that the first so that 1 the integers increase in value as each row is read from left to right, and 2 number 2 in any column the smaller integer is on top. For example, one way to arrange the 6 integer numbers in 2 rows of 3 columns is 1, 2, 4, 3, 5, 6. That we need to obey the rule number 1 that integers increase in value as each row is read from left to right. So if we are going to read per row, the values should be increasing. So first row 1 to 4, as we can see, it is increasing. 1 to 4 is increasing. The second row 3, 5, 6 is also increasing. 3, 5, 6. 3 is less than 5. 5 is less than 6. Rule number 2, any column, the smaller integer is on top. So per column, if we are going to read per column, the top column must be smaller than the next column. So the first column is 1, 3. The top column is 1 and it is less than 3. The second column is 2, 5. The top column is less compared to 5. And also column number 3, 4, 6, the top column is smaller in value compared to the second column, which is larger in value, which is 6. Another is 1, 2, 3, 4, 1, 3, 4, and 2, 5, 6 arrangement. And this is the solution. The numbers 1, 2, 3, 4 up to 2 multiplied by n are to be placed in a 2 multiplied by n positions of a 2 by n array. For example, set A is equal to the array A sub I, A sub j. That I indicates the row index, that j indicates the column index. Such an arrangement is called monotone. The array is called monotone if the values increase with each row and within each column. Then there are b sub n ways to form a monotone of a 2 by n array containing the entries 1, 2, 3, 4, 5 up to 2 multiplied by n. For instance, for example, the following is one of b sub 3 is equal to 5 of the monotone 2 multiplied by 3 arrays. So this example arrangement is one of 5 of arrangements. So therefore, to calculate using the Catalan formula these kinds of monotone array arrangement, the value of n is equal to the number of columns of the given size of the array. As indicated in the statement of the array, the size of the array is 2 rows by 3 columns. Therefore, n is 3. N is 3, the number of columns. So we will calculate the Catalan number at b sub 3 using this formula. B sub n is equal to 1 divided by quantity n plus 1 multiplied by c 2n, comma n. The value of 3 will be substituted to the variable n. So b sub 3 is equal to 1 divided by quantity 3 plus 1 multiplied by c 2 multiplied by 3. 3 is equal to 1/4 of the combination of 6 objects taken 3 at a time is equal to the 1/4 of 20. And then therefore the answer, there are 5 ways how we arrange the monotone array with an array size of 2 rows by 3 columns. That it follows or obeys the rule that uh, when we read from row, the numbers particular in a row is increasing. If we also read per column, the numbers is also increasing. Starting from the top, that indicates the smaller value or amount. I posted your fifth assignment in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.